Hello, mathletes. All right, so 3.5 operations with matrices. So here we go. So I'll talk about the vocab in a minute, but first let's just kind of review what we learned the last lesson about what a matrix is and how and about its dimensions, about the elements and so forth. And so remember that a matrix is a collection of elements. Elements can be numbers, they can be variables, they can be symbols, or it can be a combination of both. And so, and remember that in matrices we have rows and columns, right? So we have rows and columns, and rows are horizontal, and columns are vertical. To end right there. Okay, so keep that in mind. So when we're stating the dimensions of a matrix, we go row first by column. Okay, so row by column. So like for number one, we look at how many horizontal lines, how many horizontal lines there are. And so in this case, we have one, right? There's just one horizontal row there. So we go one by, use the multiplication symbol usually for the by. And then how many columns do we have? Well, we have 1, 2, 3, right? So one row by 3 columns. So this is a 1 by 3 matrix. Here we have 2 rows, 1, 2. So it's a 2 by, and then we have 3 columns once again. So it's a 2 by 3, right? Here we have a 3, 1, 2, 3 by 1, 2, 3, 4. So 3 by 4 matrix. All right. So that's how you state the dimensions or identify the dimensions of a matrix. So next we have elements. And so remember that elements, we usually state, and I showed you a notation yesterday where you say like row 1, column 3, right, would be the address. And so here's another way to do it, is just to subscript the row and column as a 2-digit number. So the first digit is the row, the second digit is the column, right? So you may see it both ways. Here's another way to see it. The book uses this method. And so we have matrix A. So each element is denoted by the lowercase a, and then its address. Okay, and then for matrix capital B, lowercase b denotes each element of the B matrix. And so matrices are usually capital letters, and their elements are usually lowercase letters. All right. So if I say identify the element, so B23, so I'm looking in the B matrix, and I'm looking for the element in the second row, third column, right? So I'm going to go down second row in the third column. So that would be the 7. So 7 is what B23 is. Okay. A42. So now I'm looking in the A matrix, and I want to go fourth row, second column. So fourth row, second column is the 2. All right. B11 or B11, right? So we have B11, so it's 1, 1, first row, first column. So we get 2 there as well. All right, so hopefully that reminds you of kind of the terminology and the structure and what a matrix is and how it works. So we're going to deal with operations of matrices today. We're going to be adding and subtracting matrices, which is pretty intuitive, I think. And then we're also going to talk about multiplication, scalar multiplication. So a scalar is usually a constant. It's usually just a single value. It doesn't have any magnitude, it doesn't have any direction. It's plain. It's only magnitude. So sometimes you'll hear a scalar used in science, in physics especially, where like velocity would be a vector because it has direction and magnitude, and its counterpart scalar would be speed, where speed is just magnitude with no direction, right? So you can be going 50 miles an hour in any direction and the speed remains constant, whereas the velocity could be changing continuously. And so anyway, but in terms of matrices, the scalar is just a constant, like 5 or -2 or 0 or 1. It's just a number, and that we're going to be multiplying by a matrix. And so scalar multiplication is just the process of multiplying that constant by the matrix. And it's pretty, once again, pretty intuitive. I think this lesson will be very intuitive, and I think you'll pick up on it very quickly. Matrix multiplication, which is what we'll get into in the next unit, that's going to be a little different, because that's not as intuitive. That you kind of have to just learn how the process works. It's not hard necessarily, but it's just not something that you just look at and be like, oh, this is how it's done. So all right, here we go.